I'm Harsh.
Eric.
Zach.
Will.
Sweet.
Okay. And today we're going to be presenting the Smart House. Whenever we have a project, we have to decide what things are important to us, how we're going to complete that project. One thing we had to consider is our time constraints. We only had about 2 months to complete a project. So that was one factor in determining what kind of project we would pick. The next thing we had to consider was the costs. We had to make it fairly low budget and make sure that we could create a project on a low budget. Another thing we had to consider too was what kind of skill sets do we have? What complements, what can complement a project? Where can we all fit in?
And clearly carpentry came into this at some point.
Yeah, it definitely did, and you won't believe where it came from.
Okay.
There's one guy going to be talking about that pretty soon. And how do we decide our project? Last but not least, we need to make sure that we can get reliable results, a reliable product that we can show you guys, and one that is active. So I'm going to start off with what is an Arduino. It is a programmable microcontroller chip. You can connect it to a computer via USB. And what you could do is you could program some sort of an algorithm, and then what you can get out of it is like you could turn things on or off. Now that doesn't sound very exciting, but when you consider all the attachments you could put on that device, such as temperature sensors, photosensitive resistors that tell how much light is in a room. In fact, you can even put a GPS module on there. Possibilities really expand from that point forward. Next slide, please. So, the project's up for debate. First up, Will talking about the weather balloon.
One of the ideas I came up with when we first started off thinking of ideas for a project was to make a weather balloon. Since Arduino is a really compact size and has a lot of sensors and components you can attach to it, while it wouldn't have been hard to attach a GPS to it, attach from weather sensors and everything, and have it go up to the sky, the hard part was just, as Sasha said, the feasibility of it and actually like the whole range of projects. So like we were able, if we wanted to, we could attach a GPS to this project and put it in a weather balloon, but in the amount of time we had, the more feasible project was the Smart House after we like went through all of our resources and time.
The next thing up was the item identifier via RFID. If any of you know already, RFID is a radio frequency identifier. It's just like a little piece of metal with like swirls of metal. And what you could do is, I mean, if you get the sensor, you could identify an object based on that alone. And that was something that Rick brought up actually to us, and that was a possible exploration field. But again, where we were a little concerned was how much experience we had with RFID, and did we have enough time to produce that one product? Last but not least, the Smart Roomba. Who did that one? Harsh.
Yeah. There was this one idea we came up with was the Smart Roomba. Does everyone know what a Roomba is? It's a tiny vacuum cleaner that goes around like circles. Like So we plan to have a chip connected to it, and we plan to have a wireless controller on our hand, so we can actually go around and see like a robot. So our implementation was to have a chip connected to it, have a little camera, so that thing acts like a security system. So if you're at work, if you're someplace else, you can see if anyone is in your house or not. You can turn on the lights, you can turn off the lights, like he said. But we also did some more research, and we found out that a lot of other universities has not the same, but similar ideas with the Smart Roomba, so we didn't do the Roomba. And also we had to see the time constraint that we had. And so we went with the Smart House.
Okay. So the project selection ultimately was the Smart House, as everyone had just said. Next up.
All right.
Take it home.
So we have a bunch of sensors that we got to show you guys last time that are inside this house. And right now, they're all connected to this computer, and they're sending data to it at the moment. So you can see on the right side, or your left side, there's all this data for temperatures it's sending back, lights that it's sending back. We have some switches over here on the side that if I change them, I can turn a little, I'll show you later, but there's a light inside that's going to go on and off. So there's also inside this little, it's called a heat sink. And one side of it, when you turn it on, the side will get hot, the other side will get cold. So because we have temperature sensors in there, we use that so that you can see that there's some cold in the room, there's some hot, you just see changes when we show you where the temperatures actually happen. And we'll show you what it actually looks like inside a little later. Take the top off.
Okay, so the Arduino, even though like it's a smart chip, we can even have Arduino chips talking to other Arduino chips, and then ultimately talking to the computer. So one of our first ideas was to have one master chip that would collect all the data and send it to the computer, and then have little chips for each set of sensors that would talk back to the master Arduino chip. And then we found out after a while that while it was technically possible, it was just a little bit too much work to have each sensor group have its own chip. So what we have inside is just having all the chips connected to one little breadboard and then to one master board which connects to the computer.
And yeah, like Will said, we have two circuits inside. Like he said, we wanted just one master chip to control everything, but that would take a lot of work, and it would also mess up all the wiring system inside. It would make us confuse more, and to others too. So we had two chips inside, which does two different things, and which also communicates with each other, and it gives the results like Zach showed you with the heating and cooling system and all the others.
Just wanted to add another reason that we used multiple chips is because what we found along the way is that all these devices that we're using take some power. So we have a light source inside that's drawing power. We have the heat sink. So we ended up at the end having a little issue with power supply. So we had to, as you see, there's the power source down here. We had to plug one of the chips in there. Two of them are plugged into the computer. All that's making all this actually work, because when without the power supply, you'll see that if I turn the light on, the temperature's going to change by 10 degrees, just because of the power that's getting drawn to it. So that was just a little interesting thing, another reason why we had to do that.
Alright, so basically for our visualization part of what we ended up doing was creating a website, as you can see right here, to show all the information. We started out, we're collecting all this temperature data, the data about light sensitivity, but what do you do with it? I mean, once it's on the computer, that's great, but you want to be able to display it somewhere or send yourself alerts via Twitter, via whatever, to tell you, oh, hey, look, the temperature's going this high, and if you want to turn your heater on, this high, and if you want to turn your AC on, if it's going this low, maybe you want to turn your AC low heater on. So what our site basically, what we ended up doing was creating a website using Amazon's web services, the Elastic Compute Cloud, which is basically a web service that lets you have a virtual machine that can be set up as a web server. And the reason we chose this is because it supports server-side scripting, which is needed to run our website. And Professor Anderson was already using other Amazon web services, and he said this would be ideal for us to just use Amazon service than to wait on Rutgers to give us access to a web source, and that would just take up time. So it'd be better we just use Amazon's. From there, what I basically did was we created a website using the Drupal content management system, which is basically an open source system that allows you to publish, edit, and modify content from a central page. It also has community-supported modules which let you easily add features onto the website. Like, for example, I have a thing here that sends a Twitter feed that will basically tell you when your temperature in the house goes over a certain threshold, and it will send out a tweet saying, hey, look, this is what's happening, maybe you want to turn your AC on. Or if it drops below a certain temperature that you set, it will tell you to turn your heater on, or however you'd like to set it up. So because of that reason, we used the Drupal content management system. And what we basically did was, like Zach said, we took all the data and we sent it to be displayed on this thing called ThingSpeak. What it basically does is it takes data from the Arduino microcontroller and processes it into different sorts of graphs, as you see here. And what we basically have is, we have those graphs embedded onto our site where it's going to show you, what this page would do is basically it shows you your temperature in the house over time. The graph on the left here shows you like the heat. So if one room had like the heater turned on, this would be basically how hot it's getting, and the other room would show you how cold the room is getting. But obviously, because of the limited space that we have right there, we had to use one sensor that had a hot and a cold side, and because they're so close together, it's picking up temperatures that are really similar to each other. But in an actual smart house, where you have rooms that are separated by walls and doors, you would actually see different temperatures completely apart, separate from each other in different rooms. So this is basically just a graph that shows you the temperature that's as it is in your house over time. And then what we also did was we did this for the light intensity over and of the light in the house. So it shows you as when the light's at full brightness, it'll be close to 0, and as it gets dimmer and or brighter, it goes up and down accordingly. And as I mentioned before, one of the things we set up using ThingSpeak is we set up basically different thresholds for when the temperature got over a certain threshold, it would send out a Twitter alert to a Twitter account that is embedded back onto your website that says, hey, the temperature is at this, just as like a warning to you. And you can also, given enough time, you can do it with like water sensors, light sensors, whatever you want. You can have different such alerts.
Okay, so house design and build. I made this little design after I first made a design where I just made an L-shaped house. It just seemed very simple at the time. And then I just stayed up one night for like 6 hours into the wee hours of the morning. These guys got an email at 5 o'clock in the morning, and I came up with this. And yeah, the rest is history. Go to the next slide. But I had some experience with building models before, and had a few ideas on how I can do it. But little did I know that Eric Bender was a big wood carpenter back in high school.
Yeah.
And he helped me out big time with this project. So, what's he before on this one?
Well, as you can see, we had a huge layout. We wanted to have the plywood reinforced on the bottom because we originally thought to have all the chips underneath, so we'd be able to show because we have multiple rooms. The house is balsa wood, the entire this part up and this up here. And this roof actually wanted to have it come off so we can show you what it looks like on the inside. And I did all the cuts and all the measurements, and I showed Sasha how to use a circular saw. That was a lot of fun.
This has been exciting.
Because he had we have a video. We're going to send that out to him. He was sweating.
Show us your toes.
Actually, no, that was the funny part was I was really sweating bullets. I even was crying at a certain point.
No, he was sweating.
No, because he tells me, like, with his long arms, he's like, okay, you know what I want you to do? I want you to extend across the table. The plywood's here, and there's only this much of a cut, and I'm like, I can't extend that far. Can you do this, Eric? And he did that once, and then he did the other side. But, that's how we solved a problem there.
I've always had an interest in woodshop. Actually, it's one of the things I kind of haven't, since I moved away from home and I'm not really near my woodshop, I kind of have withdrawals, and I discovered, in Flu Bar in Highland Park. And it was nice, and I got to go, because I really do know my way around the toolbox and all that other stuff. So it was a lot of fun. I mean, I first came as a project, and I thought about it. I didn't even know what an Arduino was. I was like, okay, what would I be able to contribute? And then Sasha said building models. I said, all right, I can do that. And I surprised everybody, and now we have this big model right here, and it's a lot of man hours, a lot of time, and it's popsicle stick reinforcement on the roof. And
thanks to me. Popsicle stick reinforcement.
And Sasha gluing himself with the glue gun.
Yep.
That was fun.
Wild blisters.
So where is this going to live now that?
Yes.
Yes.
We'll discuss negotiations for the packaging of this project after the presentation.
Yeah.
Actually, this was Marky, this was you and Zach, just putting in the wires here. Oh yeah, we'll show them. Okay, we'll show them after that.
Yeah.
So go to the next slide. Now let's actually show these people what this model can do.
Alright, well you saw all this stuff on the side. The main things with all the sensors and whatnot just one little thing to show you. So we have this little solar panel right here, and when you stays plugged in, it's just going to detect, let's say your lights went off. So I'll tell you this big light. All right, so once it updates, the lights all go on. So that you see, like, if you have no light outside, the lights on.
What are the Christmas lights in the front?
That's what's showing.
These are the lights we were going to show.
I just turned the solar panel upside down, so now it's not getting any light from the room. So now it's detecting no light. Turn the lights on. So if I flip this back over and we turn the lights back on, the lights will all go on or turn off because now you have like now it takes a couple seconds just because of how long we have in the free cycle on the chips.
Hey.
The day and night cycle. Try to do that.
I kind of want to go.
Take it apart. Yeah.
No, we can take it.
You want to actually look inside?
Actually, yeah, everyone stand up really
Come
quick.
on, everyone stand up.
This is a discussion, right?
Yeah.
I'll show you all the rooms and everything that was done. So we actually have a green couch.
Oh, there we go. Oh, that's right. I was going to donate some of Dora's doll furniture.
Yeah.
Buttons and
Yeah, so we have our 2 chips, all the stuff plugged in. This right here is actually, I can turn that. Yeah, so this is like the heat sink that gets hot.
Oh, you guys can move on.
that's where the entertainment system is. Yeah, that's a really bright.
This is a very interesting deal. Aesthetics. Oh.
It was a joint on us for aesthetics. We were going to have it.
They really just make it like
That's where the kitchen's going to go once we get this on full model.
yeah, it's like on my couch.
Hold on, you printed that couch. You did print that
This one is like all the
Yeah.
These two are just glued to the CD. So this is just audio. We're just using the system.
Rooms because the light is here, so the heat. And this was just totally fun out here. And then I had all these holes drilled here because the balsa was very thin.
Yeah, it's really bright.
That's our.
Yeah, don't look into that light.
Yeah, don't look into the light.
You will be blinded.
You saw the graphic there that showed the lights are on. This is the light. This is the sensor. The lights on. So.
Yes. That's very intense.
That's the light that was causing the temperature to go up and down.
I'm done.
So one side's hot, one side's cold. So this one's
Yeah, that's one temperature sensor.
Okay.
There's one here.
Cool. Or hot.
Sure. Go for it. Let's put it on display. We'll spring it on display.
We had windows and doors.
But again, for the time constraints.
We were able to have to paint it, make it like a Spanish style house, but time.
Time precluded.
Is it good?
All right. Actually, can you go back to that really quick? Really quick? Just really quick. As you can see, when we did turn off the lights, you saw that little dip right there. So that was another thing we just wanted to demonstrate. Last but not least,
I mean, obviously, because you're, sending the data from here out to the ThingSpeak site and then to our Drupal site, which is hosted by Amazon, there is a little bit of a lag in the system. That's why it's not going to be, as soon as that light changes, it's going to be at least a good minute or two delay. Because it is just because, like, the system, you have to send it from one server to the other. So there's just a little bit of a delay.
actually,
There was one more thing, right?
yeah, one last thing. We really
Then we'll take questions.
Now, guys, if we did have more time, what would happen with this project afterwards? I mean, we could create an algorithm for, okay, we turn on the lights at 9 o'clock when you get home at night. We can also turn on an algorithm for like, okay, I like the so maybe I want to change it to 68 right before I get home, and that would happen. But what if we were also to have a GPS module on the person, let's say? And what happens if all of a sudden you're arriving home at around 5 o'clock and you're within a 1 mile radius of your house? Well, then there would be an override, and then that could turn on. That was one possibility we considered. Next one. RFID chips again, we discussed that. And passive solar design. We didn't have enough time to do that, but this roof originally was supposed to be off-kilter, so that we would be able to implement a passive solar design. And all that is really just, you use less devices in the house, but what happens is in the summer, you would get such an environment that it's shaded within the house, and in the winter, you would have the light come in, the way the Earth is, and then you look at where the sun would be at that time of the year because of shifts, and that's why seasons change. But that was another thing we considered. And anyway, that's about it. And
that's
now we're
very interesting technology. There was a good article about this in the New York Times a few years ago. But basically, they were pointing out is we organize our house building on taxation lots, which has got nothing to do with the suitability of that particular location for building domiciles if you're concerned about energy savings. So this particular movement, I think it's from Germany, right? It's a European thing. And what they do is they very, very carefully examine where to position a house, what the orientation of the house. Like the de facto, what we do in America is the front door faces the street. The front of the house may need to face in a very different direction to be able to catch prevailing winds and the angle of the sun in that particular location and the rest of it. So it's a whole different approach, and what's interesting about it is that it's an approach that fundamentally is saying, we can have energy efficiency without going into more technology because we need to leverage the things that the Earth already provides us with, as opposed to overriding or forgoing those capabilities because it's convenient administratively to have the houses in this particular fashion, So I just love this from a philosophy of technology perspective, because we always think of more sophisticated technologies as being more technologies, and I think this is a nice example of a technology movement that is about less technology in some ways. So it's
probably the hard part of the whole thing. Building your ideas and coming six of us with all six different backgrounds, trying to bring it to one perspective thing we have. Well, let's do this. We think that at the time. We really wish we may have had a little bit more time, and we were honestly in the same thing for about almost a month trying to get it down to what we really wanted to do.
Well, that would be my first question. You guys were the experimental group in that the biggest we wanted to go was 5, and we decided to go with 6 for you guys. Do you think that the group size, and I don't mean to get into like the details of the course in terms of the logistics so much, but do you think that that smaller may have helped, or do you think that ultimately everybody, the variety of skill sets, because it's clear that you had a variety of skill sets.
No, I think the group size was fine, but sometimes when we had the meetings with more people, it's more likely to be saying that, I won't be able to come to that, he won't be able to come to that, or he won't be able to come to that. So sometimes we felt like there were only like 4 people in the thing, but we had a group of 6. But sometimes, like, we all came and we implemented our ideas onto the house, which was nice. And so
our meeting time was once a week on Monday night at 9 p.m. That was the only time that we could all make it after everyone's class was over and everything was done. But no, we got some, to answer your question, we got some big personalities, we got some really strong ideas up here. And we got some big people too as well. So I really think that maybe the group size didn't matter. It's just the idea of how everyone gets paired and how well the ideas mesh. Because we all were in the same idea after we had those ideas. Because we went, oh, what about a Roomba? What about a Smart House? What about this? And then we really had to come down like, okay, what's feasible? What's not? What's cost effective and what's not? That was probably the hardest part. The number of people, I don't know. For me, I don't know if they're going to disagree, but for me, I don't think it mattered that much.
Well, we can stick around and talk about that after the.
Actually, there were almost like two subgroups, if you think about it, and that played to an advantage in some respects, because
Because of time constraints.
like for time constraints, like me and Eric would sometimes, when we worked on the model, and these guys were working on some of the coding, I mean, you know, if we were together, it doesn't matter either way, so.
You don't need the other group to do what the other group is doing.
Yeah,
Exactly.
and that was kind of cool, because we almost group segmentized our group, and like, that was cool. One thing though, I would definitely highly recommend is definitely figure out what the skill sets of the people are before they enter the project, because for some reason, we just had the perfect group for this project. And that was what was like fascinating.
Well, but the other thing about you guys is